Hey everybody, and welcome to another writing statistics results in APA format video. In this one, we are going to do a factorial analysis of variance, but it's only going to have between subjects factors. And we're going to do a very simple design here. We're only going to have two factors or two independent variables, right? So this means dependent variables, right? And we're going to do a simple one, two independent variables with two levels each. So it is going to be, actually, let me get up here. Yeah, it's going to be 2 by 2 factorial. Okay. Oops. Factorial. There we go. And we are going to write that. I'm going to make this font a little bit bigger. Let's do 14 so you can all read it. Okay. And to get the data, I am going to use our trusty pal. If you're familiar with my channel, we're going to be using Jamovi 2.3.22 on Macs is the current, as of, as you can see, February 20th date for Macs. So we are going to be using that, and we are going to use a data set that you can get your hands on by clicking modules up here and getting, oops, there we go. Clicked it too many times. Getting the LSJ, although here I can do this, we can do LSJ, and we're going to be using this module, LSJ Learning Statistics with Jamovi from Danielle Navarro and David Foxcroft. So that's where the data is going to come from, so you can follow along with me and write your own results section along with me. Okay, so let's go ahead and open up that data, and we are going to be using the RTFM. Okay, student grades by attendance and reading. So if you understand what RTFM mean, it means read the friendly manual, where the F is actually something a little bit more coarse than that. Okay, so we are going to use that data set to get us going. So I'm going to go ahead and open that, and it's going to not show us the data, so I can click this over. There we go. And it's a small data set, and we are going to have these 8 people see whether or not attending class or reading, or maybe the combination of both, yields the highest grade in class. It's almost like a teacher made these. Anyways, let's get us going here. I'm going to write some things that aren't going to end up in the result section, just to get us set for how we need to write this, because not only do we need a set of descriptive statistics that we're going to be using, but we also need to know just various names. Use grade, attend, and reading, but really we kind of want to use stronger English for these, if you catch my meaning here. So it's a 2 by 2 factorial, but really what we want to say is the design is a 2 by 2. You can use those fancy X's if you want to, that sort of lift it up and thin out the lines just a little bit. I tend to not use that. Between subjects design, okay? And one of the IVs, it's gonna just do IV1 instead. IV1 is going to be reading the manual, and IV2 is going to be attending class. I know I have that backwards here, but it's, you know what? Actually, I say that. I'm going to switch it. So let's do IV1 is attending class, and IV2 is reading the effin manual. Cool. Okay, and then our DV is grade in the class. Okay, so here we have 8 people. So our N equals 8. Okay, and we have a 1 or a 0. And 1s mean yes, and 0 means no. That's how you read this data set. Okay, so for person number 8, they got a 90, and they attended class and they did the reading, but we have a 65. Person number 7, 65. They attended class but didn't do reading. Okay, so that's how we're going to do this. All right, let's get the data, and then we can start writing this up. Now, if you were writing this in a paper, you would probably have all of this information in your result section, or excuse me, your participant section, because I'm going to say factorial here. Actually, I'm going to throw in factorial design, because that's the stuff that goes into the design part of method, and how many people participated goes into participant section. So this is stuff that would already have been written, but hasn't been written in this video because we're just writing the results section in APA format. Okay, so the results are going to appear here. Okay, so let us grab the ANOVA. So I'm going to quickly do this. You can go see my other videos on how to do ANOVAs in Jamovi. I have 2 playlists, one from older sets of Jamovi, from an older version, 1.8, I think was where I did most of that work. And then I have a 2.x playlist on how to do it in Jamovi in the more recent versions. So let's go to ANOVA, and we are going to go just to the ANOVA module, and here we put our dependent variable. And even though it has the continuous variable sign, it's going to allow us to do this because it is at least numerical. And then we're going to put attending and reading in the same order, and we're going to put those into fixed factors. And I'm going to go ahead and grab the overall. No, I don't need the overall model. I would like to get partial eta squared. Eta squared is an effect size for ANOVA, and partial eta squared is for each of the effects that we're asking for. We have 2 main effects and 1 interaction that we need to discuss in this results section. Other things that I would like to get would be homogeneity test and the normality test. I would like to get all of my post hocs, even though I don't really need attend and reading, but I would like to get that anyways, just in case. And instead of Tukey, I'm going to use a Bonferroni correction. I just appreciate that a little bit more. I also want Cohen's D for my pairwise comparisons, and might as well get the post hoc or the confidence interval for that. And then I would like to get my estimated marginal means. I'm going to drag attend, get a new term, get reading, and then get attend by reading. And this will give me all of my marginal means, which are important for doing ANOVA. Okay. Oops. Actually, there's one thing that I wanted. I want the table. I like the table a little bit more than the plots. As far as the plots, I would like standard errors. And that's all I want. Okay. So I'm going to hide this now because I don't need any of it. I want the results. You won't let me go all, there we go. I was like, you won't let me go all the way? How dare you? I am also going to make this a little bit bigger for you so you can see a little bit better. So 150%. Love it. Okay. All right. So we've got a lot of information that we have to condense down into the writing of this results section. Okay, so we have the ANOVA, which gives us 3 tests, okay, 3 F tests. We have the main effect for attend, so attending class on the top row, for reading on the middle row, and for the interaction of attending class by reading on the third row, and then we have our error term on the final row here. Okay. And then we have Levine's test. Homogeneity of variance is pretty darn screwed here, which means we have a heterogeneity of variance. And the issue is we have only 8 in our sample size. So it's hard to, we're going to ignore the homogeneity of variance test, but it is important to say the homogeneity test was violated here. The grade was normally distributed even with 8 people. That's nice. It's actually pretty normally distributed. And then here are our post hoc tests. We'll find out a little bit more about this one and need to add them into our result section here. Here's the graph and the means for our attend variable. Here's the graph and the means for our reading variable. And then here is the attend by reading interaction graph and the table. So we're going to do this one at a time. Okay. And so here's how I like to do this, which is going to be different from the other videos that I've created for other kinds of more simple analyses. For Factorial ANOVA, you kind of want to do this one at a time per effect. So I usually do 1 paragraph per effect. And so I'll take my 2 main effects and I'll go in order. So we'll do attending class in paragraph 1. We'll do reading the F and manual in paragraph 2. And then in paragraph 3, we will do the interaction between attending and reading. Okay, sound good? Again, pause me, speed me up, slow me down anywhere you need to in this. I know I speak a little fast in these. I've sped up my voice just to make the episode lengths more palatable. I appreciate everyone using the controls to make it work for them. Please use those controls. I also like how he sounds sped up. I feel like I speak too slowly in general. So anyways, that's neither here nor there. All right, let's write the results. So one way to start is, again, I'm going to tab. Oh, I don't want that. Oh boy, why is that tab? Get out of here. There we go. Regular tab. Okay. A 2 by 2 between subjects ANOVA, Factorial ANOVA, Factorial analysis of variance ANOVA was conducted to determine the main effects of reading, attending parallel construction, attending class, and reading the manual on a student's grade in the class. Okay, that's my first paragraph. It's a single sentence paragraph, but that's okay. All right, and then we move on to the next one. I'm going to do an extra space in between. I don't do an extra space normally in between. It's just I want to break it up for you all to be able to read, and I'm going to increase the magnification here for you all. Let's do that. All right. So we are going to talk about attending class. So in this paragraph, I'm going to have my descriptive statistics followed by F9, followed by my inferential. Now, descriptive is mean standard deviations. Inferential is the F test. Okay. And this is attending class. Okay. So I'm going to get my details from this. So let's go to the marginal means here, because that's what you want to report. We want the marginal means for attend. But if you take a look, we only have standard error and not the standard deviation for each of these, which is a little bit of a bummer. Okay. So descriptives are a little weird. You can see here that we only have, let's go up to attend here. We only have the standard error and not the standard deviation to get for these means. The way you do this is you just multiply by the square root of n to get the standard deviation, because the standard error is the square root the standard deviation divided by the square root of n. So we can get the standard deviation from doing that. And that's because this is the average of all of my attend to people, regardless of whether they read the manual or not. So this is no, and this is yes, but it's average across 2, and that's why these values are different. And just to show you, I pulled up the descriptive statistics, and you can see here that none of these are there, but we do have an N of 2 in each of these groups. So what you do to get the average is you get attend, and you average these 2, and then you get attend, and you average these 2. But you can't really average standard deviations like that. So we're going to use 2.98, and it's looking like 2.98 is a standard error for this particular group. So let's go ahead and write our descriptive sentence and go from there. So how I'm going to say this is for students who attended class, and then I'm going to put mean equals, comma, standard deviation equals, and then I'm going to put a close parentheses because I want to copy and paste this a bunch. So I'm going to italicize that and italicize that. Okay. They achieved, no, I'm going to do this. Students who attended class achieved a higher grade in the class than students who did not attend class regularly. And then I'm going to put this right here. Oh, nope. See? I thought I hit control. There we go. All right. This difference in course grades was statistically significant and yielded a main effect of reading on, or not reading. I keep doing that, guys. I'm sorry. Attending class on grades, comma, F. And now we scroll up to this. So how you do this is you got 2 degrees of freedom. You got one for the numerator, which is on the row of the variable, and then another one for the denominator, which is on the row of the residuals. And so you do 1, comma, space 4. And so it's going to be F parentheses 2 different degrees of freedom, okay, equals some number. And here we have 18.25. I usually only do 2 decimal places, comma, whatever that p-value is. That p-value is right here, and it's 0.013. So we're going to put the whole p-value there. Okay, I usually do p-values as 3 decimal places. And then we're going to put in a partial eta squared. And we are going to do a character. Here we go. I already have eta selected. And then we're going to do superscript 2, subscript p. And no subscript equals, that is, I told you no subscript anymore, equals 0.82. Okay. And if you're familiar with partial eta squared, it's pretty much like a partial r squared. And so it just tells you the effect of attending class on your DV, or in this case, attending class on grades. And so it reflects a large effect if it's going to be a very large effect if it's 0.82. We're talking 82% shared variance between these two. So attending class does have a significant contribution to the variance of grades. Okay. And period. Okay. So those are the F statistics. And I'm going to italicize the things that need to be italicized. Latin letters italicized. So we've got an italic F. We've got an italic P. We do not italicize Greek letters or any subscripts associated with them. Let's put in our means and standard deviations. So 2.98, I'm just going to do some math off camera here. So the square root of 8, oh boy, what is the square root of 8? 2.828 times 2.98 equals 8.43. Okay, so 8.43 and 8.43. Although we could do this standard deviation if we really wanted to. So if you have 2 groups, I have 2 K groups. If you want to find the average standard deviation among K groups, and each group has the same sample size, you can use the following formula: the square root of the variance added together divided by K, which I'm just doing the standard error divided by the square root of K. So I already have that. Yeah. So it is 8.43 for both of them because of equal sample sizes. 8 essentially. And so we are going to skip the descriptive statistics here. Okay. We're not going to be using that. All right. And so our means here are 57.5. And down here we are, and you know what? I'm going to put a 0 to make it all the same. And then 75.50. Okay, and that just tells you that, and if you look at these two, it's like, yeah, you should attend class. That's so much better. Okay. And then so we're going to do the same thing here with our next paragraph. I'm going to just do an extra space. All right. Let's see here. Students who read the Flippin manual, just for flair, manual achieved higher grades. And here I'm going to look at this one here. Ooh, that's almost a 30-point difference. Achieved higher grades. And we're going to copy and paste this right here. Hello, there we go. And don't worry, I will change those higher grades than those students who did not read the Flippin manual. All right, let's change some of these numbers. 52.5. Oops. Oh, I'm sorry. I messed this up. 75 up here. I put them in the wrong order. My bad. And 57. Luckily, they were reverses of each other, and I caught that error before everybody was like screaming at me in the comments like, dude, you got the wrong order. Yes, students who achieved class got 75.5, and those who didn't, 57. So let's do this in the right order here. So 80.50. And we already know what the standard deviation is for these marginal means. It's average standard deviation. And then over here is 52. See, I didn't have to change much. And then we can just copy this whole thing. And don't worry that you're saying the same thing over and over again. The difference in course grade was statistically significant and yielded a main effect of reading the flippin' manual on grades. And scrolling back up to our thing, we've got 1 and 4. And then we've got an F of 44.17. Holy moly. And that p-value is 0.003. So let's change this 1 to a 3. And then partial eta squared is 92. I only had to do one change there. All right. So we could translate this difference here by using the Bonferroni corrections and getting our Cohen's d, but you can see that these Cohen's d's are massive, right? Because it's 0.3, 0.5, 0.8, which is the 0.8 being large. You can see that these are way over that. So we don't need the post hoc comparisons for that because there are already basically paired comparisons here. The last paragraph that we need is the interaction. And how you talk about interactions is different from how you talk about mean effects. Interactions are the combination of two or more variables. And so you need to know whether or not changing in one level of one variable changes the level of another variable. And so you use what are called simple effects to do that. But we can do this using the attend by reading marginal means if there was an effect. Luckily, there is no effect here, so we don't have to worry about it because these two lines are effectively parallel. I know they're not actually parallel, but it just goes to show that, you know, when you don't read and you don't attend class, right? 0 and 0 for both, you don't do too well in the class. It's pretty yucky at that point. But reading helps. Reading the manual, reading helps, attending class helps, but reading and attending the class at the same time, right? Doing both of them doesn't actually get you to a point of having better than anyone who just reads but doesn't attend class or attends class but doesn't read, if that makes sense. So I'll try to put that in this paragraph as succinctly as possible. So when we write interactions, we essentially talk about the F statement first, okay, and then we talk about the simple effects. Now, it's going to be a little weird talking about a simple effects when we don't have a significant interaction, but bear with me here as we go through this. Okay, so we are going to say that, how do I want to start this? The ANOVA revealed that there was not a significant interaction of attending class and reading the manual. I'm not going to put flipping in here on course grades. And then I'm going to put my F stat here. I'm just going to copy and paste it. Right. So F1 of 4. Okay. So we're still going to use 1 and 4. And here we have an F less than 1, which if you have an F less than 1, you know that it's not happening. 0.23. I didn't mean 0.26. P is equal to 0.66. And you can put 0.660 if you wanted to. If it's a 0, I don't usually put it. And partial eta squared is actually 0.05. So it's a small effect. Now, if we had more people, I imagine this interaction would actually change. It might be significant depending on what the added information was, but it definitely would change. And if the partial eta squared holds, then you can imagine that this would be a small effect. For now, it's not significant, okay? This means that though not reading or not attending class, parallel construction, not attending class and not reading yielded the lowest grades in class, reading and Jupers attending and reading did not give a stronger advantage to students in the class. In other words, students who attended class did better than those who didn't attend class, and those who read did better than those who didn't read. But reading or attending and reading weren't significantly different from either just reading or not just attending and not reading, or reading and not attending. I.e., just to make sure that everyone gets it, i.e., doing one or the other. Now, I would probably say figure 1 illustrates the lack of an interaction, okay, as the two lines are parallel and change at the same rate. All right, there you go. That's an interaction. Now, let's say there was an interaction. Say if there was an interaction, I would say something like if you read, and I keep doing that. I should have made red IV1, guys. If you attended class, or if a student, let's do that. If a student attended class and read the manual, they were significantly stronger in their final course grade And then I would put, a mean and a standard deviation. I'm not going to put those pieces of information there because I would just make them up anyways, and I don't know what to make up right here. Honestly, on camera, in the moment, I don't know. They were significantly stronger in their final course grade than students who only attended class or only read the manual, but not the other. And then in here, I would put, a mean and a standard deviation. And oops, sorry, y'all. Split this up so I don't do that again. But not the other. And then here I would M and then standard deviation. And then you could put specific ones. So for example, attending and reading was significant. And in this case, since it's a 2x2, we would report a t-test test info here. And where you would get that, Dr. Swan? Well, you would get that from the post-hoc comparisons here, where we're comparing attend and read to attend and read. And so we would go through here and see if there are any significant effects. So there are a few, although let me see here. Did not attend, did not read compared to both is significantly better. That's 0.009. The rest of them are not. And so we already know that. So I'm actually not going to report that because we already know that's the case. And we can find that that's the case right here. That was the one that I just pointed out was this dot compared to this dot. Okay, so of course that's going to be the case. Really, we wanted to make sure that really what we wanted to see is if this was better than this. So let's see, not attending class, but reading the manual, right? Not attending class, but reading the manual, because one is orange here, right? Versus attending, but not reading. So that's what we want to find out, right? So attending, but not reading. Okay, attending, but not reading. I believe attending, but not reading is this one. Okay. No, attending but not reading is this one. Sorry, down here at the bottom. Okay, attending but not reading, and then we want to compare it to reading but not attending, and that's where you can get these means and standard deviations. Reading but not attending. Reading but not attending. Reading but not attending. So this is attending and reading. Reading but not attending. Where are you? Where's that comparison? I think that's right here. Let's go down here. So reading and attending is this one here. 62.5 versus reading but not attending. Attending but not reading. 62.5. Yeah, that's this one, right? No, that's this one. 62.5. And we compare that with not attending, but reading. This one, 72.5. So it's a difference in 10. Oh, it's this one. I found it. It's right here. It's a difference of 10. So that t-test is 1.68. Okay. And that Bonferroni p-value is 1. So no. It's a big effect though. Look at that. 1.68. Oof. Rough. Okay. But that's where you would put the t-test info. I'm sorry we went through all of that. Maybe I'll cut it. I don't know. Maybe it was cut. Maybe I left it in. I don't know. You leave your comments on that down below. So anyways, I would put that mean and standard deviation stuff in here. And for example, attending and reading was significant when compared to attending but not reading, or attending, or not attending and reading t-test info here. That's where I would go with that. But honestly, reporting the that there was no interaction is essentially all you need to do for this kind of test, because if there wasn't an interaction, then you don't really need to go any further with explaining that there was no interaction, because there's no point. But you do need to mention if there are main effects. Now, this would look different if you didn't have a main effect. You would say the difference in course grade was not statistically significant right here, and then you would use different wording for achieved higher grades. Had the same grades, had equivalent grades, whatever that may be. That's how you would figure it out. All right, so that's how you do the results for a 2x2 between subjects factorial analysis of variance, ANOVA. If you have any questions, comments, suggestions, concerns, leave those in the comments down below. I appreciate all the feedback everyone gives me. Be sure to like and subscribe, and I'll see you in the next video. Thanks for watching.